This first video we're going to be talking about rational expressions and how to simplify them. First, we want to talk about what a rational expression is. It's basically just a quotient of two polynomials. So a division or a fraction where the numerator is a polynomial and the denominator is a polynomial. So a few examples. 3 over x plus 2, that's an example. X over x squared minus 4, and let's see, 2x over x squared plus 5x plus 6. So all three of these are examples of rational expressions. Both the numerator and denominator contain polynomials. Now, because we're dealing with fractions, we have to make sure to exclude any value for x that would cause a division by 0. So if I'm looking at this example over here, 3 over x plus 2, I have to make the statement that x cannot be negative 2. And the reason why is because if x was negative 2, I would be dividing by 0, because negative 2 plus 2 is 0, and 3 divided by 0 is undefined. So I have to make that statement. This one over here, it's a little less obvious what x can't be. So what we're going to do to remedy that is to first simplify it by factoring the denominator. Now you'll notice that the denominator is a difference of squares, and that can be factored as x plus 2 times x minus 2. Now I have to make the statement that x cannot be positive or negative 2. If it was positive 2 here, this would create a 0, and 0 times whatever that is 0, and you'd have this value divided by 0, which you can't do. And if it was negative 2, negative 2 plus 2 is 0 here, and it would cause the same thing to happen. Let's look at this example over here. Let's factor the denominator. It's a basic trinomial, so we have x plus 2 times x plus 3. We have to make the statement that x cannot be negative 2 and x cannot be negative 3. If x was negative 2, you'd have a 0 here. If x was negative 3, you'd have a 0 there. And again, you'd be dividing by 0, which is undefined. So for these three examples, we really didn't simplify in terms of canceling any common factors from the numerator and denominator. All we did was we simplified the denominator by factoring the denominator. What we want to take a look at now is to see how we can simplify these expressions not only by just factoring but also canceling if we can. So what I'm going to do is I'm going to write down the 3 steps that you want to follow when simplifying rational expressions. So the first step is to factor everything. Factor both the numerator and the denominator. Second thing you want to do is cancel any common factors that show up into the numerator and the denominator. And lastly, just like we did in our first 3 examples, we want to write down what the restricted domain is. So you want to follow these 3 steps when you do any examples for simplifying rational expressions. So let's do 3 examples, varying degrees of difficulty. So we'll start with, we'll call it an A problem. We'll say 3x to the 4th minus 9x cubed over 6x squared. So what we want to do first is we want to factor wherever you can. The denominator, we're not going to be able to factor that. It's 6x squared. In the numerator, we have the GCF of 3x cubed. And remember, the first step of factoring is always finding out the greatest common factor and factoring that out of the expression. So that leaves us with an x minus 3 in the numerator. So we're done factoring. The second step is canceling any common factor. So we have a 3 here and a 6 here. That divides evenly. So 1 and a 2. X squared goes into x cubed, so that cancels that to be an x on the top. So what this becomes is x times x minus 3 all divided by 2. At this point, we're done with factoring and canceling. Now we just have to write down what a restricted domain is. If you look at just the simplified final answer, you don't have any x in the denominator. So you would assume that there's no restricted domain since there's no variable in the denominator. But, and now this is a really important rule, you have to check not only in your final answer, but every single denominator right from the very beginning. So, even though there's no x here, there was an x here, and there was an x here. X cannot be 0. The reason why is because if x was 0 over here, 0 squared is 0, 0 times 6 is 0. You'd be dividing by 0, and you can't do that. That's undefined. So that would be your answer. This is your simplified version along with its restriction. Alright, let's look at, let's call this a B level. Let's say we have a y squared plus 7y minus 18 divided by y squared minus 3y plus 2. So again, the first step is factoring. So it looks like we have two easy trinomials. So we'll factor the numerator and denominator, and then we'll see if we have any common factors that we can cancel. So we want to get the y squared in the numerator and the y squared in the denominator. Now in the numerator, this tells me I'm going to have different signs, so one's positive, one's negative. This tells me that the larger number is going to be positive, so my larger number is going to be here. This says that they're the same sign, and they're both negative. So I need two numbers that multiply to give me 18 that combine to give me a positive 7. So what you're going to have is a positive 9 and a negative 2. Over here I need two numbers that multiply to give me 2 but add to negative 3, and that would be negative 2 and negative 1. So let's see if we can cancel anything. Y minus 2 shows up in both the numerator and denominator, so we can cancel those. So now we have a y plus 9 over a y minus 1. Let's write down what our restrictions are. My final answer, I see that y cannot be 1. And over here, can't forget about that, even though we canceled it, y cannot be 2. So this is our answer here. Alright, let's do C problem. So it'll be the last one. So we have x to the 4th minus 1 over x cubed plus x squared plus x plus 1. Okay, so let's factor. The numerator is a binomial, and there's no GCF up there. So we want to ask ourselves, is it a sum or difference of cubes, or is it a difference of squares? Or is it prime? It looks to me that it's a difference of perfect squares. So that will factor to be x squared plus 1 times x squared minus 1. And I'm just going to make a little star right over here, because I know that this here is going to be able to be factored more than where I already have it, because this is also a difference of squares. This is a sum of squares, and remember, when factoring, you can't factor a sum of squares, only a difference of squares. So down here I have 4 terms. That usually indicates the fact that you're going to have to group. So let's group those two together and those two together and see if it works. So for these two, I'm going to factor out the GCF, which is an x squared. And I'm going to need an x and a 1. Over here, there's no GCF, so I'm just going to pull out a positive 1. And I'm just going to write x plus 1 here. So this groups perfectly because I have a common factor here and here. So let me rewrite this, and I'm also going to factor this difference of squares up here. So I'm going to have x squared plus 1. X squared minus 1 is x plus 1 times x minus 1. It's a difference of squares. Over here, I'm going to pull out the x squared plus 1 and the x plus 1. Remember, this and this are common. They're common factors. So if I take out the x plus 1, I'm left with x squared plus 1. So let's see if we can factor anything. We have an x squared plus 1 over an x squared plus 1. Those are common. Let's cancel those. An x plus 1 over an x plus 1. Those are common. Let's cancel those. I'm just left with an x minus 1. Now I have to write down my restricted domain. This over here, I cannot have negative 1 as a possibility for x, because that would cause a 0 down here. Over here, there's no restrictions for this, because no matter what x is, you're squaring it, and then if you add 1 to whatever that is, it's going to be positive. There's nothing over here because this isn't factored yet. This is the factored version. So actually, this is my only restriction. So let me just get rid of that. So this is my final answer. You only have one restriction. And that's it.